Alright, so this lesson is on exponential and logarithmic inequalities. Take a look at our first two examples. Notice the equal sign and the greater than symbol. This is known as an inequality. Equal sign, inequality. So here we have a greater than symbol, here we have a less than or equal to symbol. So how do we solve inequalities? Well, first we solve them just like we would when we solve an exponential equation. We want to make the bases the same. So we're going to convert 27 to base 3. So that's going to give us 3 to the third power, which is 27, raised to the x. Okay, so now that our bases are the same, we can cancel those out. We get 3x, 3 times x is 3x, greater than 2x plus 3. Solving for x, we're going to get rid of the 2x, so subtract the 2x on each side. X is greater than 3. So anytime we're dealing with an inequality, we want to test our answer to see if it's true that all values greater than 3 work in this problem. So if I choose a number greater than 3, let's check 4, we get 27 to the fourth power is greater than 3, plugging our 4 in, we get 2 times 4 is 8, 9, 10, 11, 3 to the 11th power. Okay, so checking 4, we see that the left side is indeed greater than the right side. Now if I check a number less than 3, check 2, we notice that the left side is not bigger than the right side, so check 2 does not work. Okay, and obviously 3 will not work either because there is no equal sign present. Alright, let's take a look at number 2. We have 3 to the negative x is less than, changing to base 3, 3 squared. Canceling out our two bases, we get negative x is less than 2. We have to divide by negative 1. Remember that when dividing by negative, your inequality flips, so we get x is greater than 2. So all values greater than 2 should work in this inequality. So let's check 3. So we would have 3 to the, plugging the 3 in, we get negative 3. That should be less than 9. And that 3 to the negative 3 would be 1/27th is less than 9. And that's true. That checks out. Okay. Next one. Okay, I'm going to have you do this one. And I'll check that one tomorrow when I see you. Number 4. Go ahead and do that one as well. Should be able to do that. Number 5. Okay, this time we cannot make the bases the same. So remember that when you have an exponential inequality or equation, we have to change forms. So changing forms, we're going to have n log base 3, okay, of 14, okay, and then our symbol. But our symbol here, when we do go around in a circle like this, our symbol is going to change directions. It's less than 2x plus 3. Okay, So our symbol changes directions when we change forms. And I believe the reason for that is since exponential and logarithmic are inverses, we have to change the symbol. So let's see what we get here. So log base 3 of 14. Remember, to handle that, we do log, we do change of base, we do the log of the argument divided by the log of the base. So 2.4 approximately. Okay, and we're going to subtract the 3 and then divide by 2. And we get negative 0.29, let's go negative 0.2989. Less than x, or x is greater than negative 0.2989. So let's substitute our answer. It says check answer by substituting the answer into the original problem. The problem is that there's no equal sign here. So if I plug the answer in, this should actually come out to be equal. Okay, let's see what we get. So what I'm going to do is I'm going to take my answer and I'm going to store it. So I press the store button that's down here. Okay, I'm going to store my answer in X. Oh, I'm in Polar. Hold on one second. From calculus, pre-calculus. Alright, let's try this again. So I'm going to store it in X. Okay, clear it. So 3, I'm going to plug it in here. 3 to the 2x plus 3. So 3 caret 2x. Now remember, the value of x is our answer, plus 3. So 14. And 14. So our answer is correct. But in order for this to be less than, all values of x have to be greater than this number. So I could choose a number greater than this value and it should work. Let's choose an easy number greater than this. Let's check 0. That's an easy check. 2 times 0 is 0. 0 plus 3 is 3. 3 times 3 times 3 is 27. So is 14 greater than 27? And that does not work. That does not work. 14 is not less than 27. So let's check a number on the other side. Let's check negative 1. So 2 times negative 1 is negative 2. Negative 2 plus 3 is 1. Is 14 greater than 1? Yes. So what that means is that this symbol that we switched it to should stay the same. So we're going to go back and make it a greater than symbol. And that's why we check our answers. Sometimes you do have to switch it depending on your check. So keep that in mind. You may want to just solve this like normal. Number 6, solve it like I just showed you, and then check 1 below the number, 1 above the number that you get, and then determine what that inequality should be. Okay? So we'll talk more about this tomorrow when you come to class. So do that one for tomorrow as well. We'll see you guys tomorrow. The color for today is blue.